do our protocols. Good afternoon and welcome everyone. This is Phil 301 for Main Campus preparatory revision session for our for our term assessment, God willing, next week in person. I have communicated on this. I hope that people have taken note of it and they will not be absent to lose an additional 30 marks to what we have been doing so far in class. The 30 we'll do in the IA should add to what we'll do there. We'll just work at 30% from everything we've done so far, then an additional 20 from the exam, I think, and then subsequently what you do in predicate logic will also constitute the other half. Okay, so we want to quickly go to the content, what I was projecting on your screen a moment ago. I was just saying that suppose I gave you this as your first formula, so you see it on your screen. Let's add one more, then we can work. And then let's say the second one is let me give a realistic one so you can do the derivations. What are the types of proofs we have? We discussed it the last time as a way of revising. What are the types? We can do a chorus answer, don't worry. Let's give chorus answers. What are the types of proofs we have, please?
We have three types. We have the conditional, we have the direct, and then the conditional proof.
Okay, how you wish those questions will come in the exam, right? So we have direct, indirect, and then conditional proof. Which other one is called RAA, reductio ad absurdum?
Indirect.
Very good. So if we had that formula on your screen now, and suppose you were asked to prove, therefore, what can I want something a bit far away, therefore not P, for instance. I am trying to this proof if you were using indirect proof, reduction ad absurdum. What is the method? So please raise your hand now, because we are revising for the benefit of those who may still not know what to do. If we're using reduction ad absurdum to prove not P, I just want the method. That's the indirect proof. What will we do first and foremost? Where is my phone there? Okay, so I see a good number of hands. I'll take Ian. Michelle. Michelle, let's take Michelle first. Michelle, what would you do first?
Okay, Miss Nancy, please, you negate you assume a negation of the conclusion.
Excellent. Which will now be what? So I just want to see, yeah.
Which
so
will
what
now
will
be a
we write
negative P.
Excellent. So
You
we'll have to write
I.
We assume that. Well done. So where is my screen? Share, Charlie. I'm Balmiari myself as over here. Okay, so we'll go to 2, and then we will say the negation of the negation P that was given. And we have told ourselves that don't ever write just the P. When you're doing derivations, if you have negation P, its negation is the negation of that negation P. So we assume negation of the negation P for what? For indirect proof or for reductio ad absurdum. You can write any of those there for your own referencing. Okay, in case you are combining more than one. And then with that, what else are you looking for? Don't do the work itself because we haven't checked whether this will be a good proof, but just to get the method. So please, which of my TAs is online now? Make a note of Madame's effort, please. It will be rewarded. She's Michelle. We'll take the full name. I have the full name here.
Miss Nancy.
Yes, my lady.
Dr. Nancy.
Oh, don't
please,
worry. Yes,
it is not Michelle. I'm using
someone
else's
device.
Hey,
that would have gone to someone's account.
Habiba. It's Habiba.
Oh, it's Habiba. I can make Habiba out. So that's Habiba. Say, any of my TAs, please prompt me. Let me know which TA is here or keeping records. That's better because I suspect all of you. Who is doing that? Is it Mr. Bosa?
Yes, please. I'm here.
Okay, Mustafa is also here. Okay, Mustafa, then please do this for me for today. Okay, so that was Habiba. Let Sadia go into her marks. We all know Abiba, she sits in front there. So you do the records for me so that right after class I can take it and update my file. Very good. So Habiba says we will quickly do a negation of the given conclusion. Why? Because of the method we are using. We are going indirect proof, fermentation. Fermenting our corn before we use it. We are not doing the normal regular akpele where we just go straight and blend our corn to get a powder. This one we will soak it and make it ferment. We are doing a negation of the original conclusion given, all in the bid to find out what. So Madam's first point is well noted. It's a good revision for those who may have forgotten indirect proof method of derivation. So what next? I think I can take Bismarck now. Oben, your hand was up. It's gone down. So you join the queue at the back there, but it's fine. Let's take Bismarck. After that, the next person to speak is Gloria. Actually, Bismarck, go ahead. Bismarck.
Madam, please. Then you do like material implication on premise 1.
Don't worry, that's fine. What I was even saying earlier was this might not work out because it's not a proof I have confirmed. I just want to know if you had to do this, what will you seek to do next? Please, you understand? I want to see if you know the how, not even to apply the rules immediately to the specific rule, what we are working on, but what is the next thing to look out for? When you do the negation, what should you work to show next with indirect proof? You
Madam,
understand
please.
me? Uh-huh.
Madam, please, you work to show like negative P.
In other words, let me help you out. You work to show that there's a contradiction. So you are going to do all you can to generate a contradiction. Please, do you remember this man?
Yeah. Yes, please. Yes.
Okay, so that's the point you are making.
I'm just thinking.
Yes, you're welcome. I come in because we are not using an actuality. I just want to hit on the reminder on the method so we don't have to do everything again. It will be overwhelming for someone who is still trying to get the key points after the whole process has gone on. So when we are doing direct proof, the first thing we look out for is a negation of the given conclusion. We want to make sure the conclusion, this is the conclusion given, and we work with a negation of that. Then as soon as we get the negation of that, we apply the rules correctly per line according to what is available to do and the question we have been asked. Maybe we're told to use only rules of inference or only rules of replacement, or apply only modus ponens and modus tollens to this question I give you, blah, blah, blah. Those can be there. But as you do that, what should be the next thing to look out for? Work along the line to create a contradiction. A contradiction is something, some formula and its own negation. So maybe if I get a not P here, correctly done, of course, and then as I advance, I come to line 4 or line 5, and then somewhere there is a not P. As soon as I have that on the line, correctly done with a narration on every line, we have learned that already. Every line correctly justified. There is no azan. There is no, oh, I think that the way I see it, it will be look that killed John. It's not how you see it. If it's about how you see it, and a lot of people were seeing something else, but the outcome of the elections is something else. So give us justification is deductive logic. So every line will have to be clearly justified. We've gone past that right now. They're just picking out the key things to help for easy revision when we are doing indirect. Okay, so we say after doing our revision, let's make sure that we now work to create a contradiction. Why? Because we want to show that when we negated the given conclusion, it generated a problem along the line. So which contradiction per this awam? This would all have a narrations here. But for now, we want to skip it. Let's say there was a line 3 that was something else, and there's a narration here. Now we have line 2 and line 4. Then we quickly come to show that, look, on line 2 and line 4, we have a contradiction. So we show that we get this by conjunction of 2 and 4, and there is a contradiction. This is another thing I want to remind you to look out for when you are doing indirect proof. As soon as the contradiction is created, mark that line. Let us know that you know contradiction. You know that we have something and its own negation, and that cannot be admitted in any rational engagement of language. So you point that out with the sign, the linguistic sign there, to show us that it is a contradiction. Just like we learned in testing for validity in elements of formal logic, we close the path that contains a contradiction and we open the path that can still allow for further engagement. You see that? So that is what we've done. Look out for that because we will mark it. We will mark that. I want you to understand. Don't be sluggish. Don't be dismissive. Don't take so much for granted when you are working. We will mark it. Where is my thing? Yeah, there we go. So when we have that and you show the contradiction, the recording I shared on the platform from City Campus's engagement pointed out some things to you. We are going to help ourselves remember again. What was that? Now we are ready to indicate that we shouldn't have done a negation of the given conclusion. We should not have negated our not be. So that is line 6 now. What do we say? It is not correct to have done the negation of what? Negation P. Do you see how many negations I've done? The 3 of them. Because this is what we did here. Look up. This is what we did here. What we did at line 2, what we assumed for indirect proof. We prompt ourselves at line 6 as soon as a contradiction is created on line 5 per our screen. We see that there's a contradiction here. So we tell ourselves in line 6 that we should not have negated the negation P. You see that? So the original not P is there. Then we did a negation of that not P, and it has created a contradiction on line 5. Line 6, we cancel out what we did earlier. So we say it is not appropriate to have negated the negation P. That's how we have. How can we have 3 negations there? Okay, so that by double negation, this and this will cancel out implicitly. So then we are ready to do our discharge. Why the discharge? We discharge in conditional proof and indirect proof, remember, because that is where we do assumptions. We assume. We are working with assumptions, not with what was originally given to us in the test case at the court there. Remember, we are assuming it for the purposes of what? Discussion. That is what it means. Direct proof, there was no assumption of anything. So when we finish, we don't discharge anything. We don't spell out anything that was wrongly brought in for the purposes of argumentation. But when we do indirect proof and conditional proof, we have to spew out what was assumed. That is what discharging means. So you will have to discharge from where you did the assumption. Hey, people should come in early. They keep going and coming. My classes are locked. So if you are coming, I have to admit you. It can get a bit frustrating for you. Tell people to get good network and remain. Right. I'm never boring now. I mean, okay, so we continue. I was just explaining to you why it is important to have in mind discharge when you are doing indirect proof and conditional proof. Why those ones? Because those are the ones that you assume you added something that wasn't originally a part of it. Now that that is clear and you are reminded of it, we go back to our thing. So then what? So if we say that we should not have done that assumption that we did in line 2, this is our test case, then it means that line 6 is telling you revert to the original. Okay, so we'll therefore say, look at from line 2 where we did the assumption. Please watch all the way to where we confirm that we should not have done so. Here, look at the things I've circled in red. We will look out for them. It's not just the lines that you are justifying, but we will look out for these. So here, line says it is important to know what a test that has been done on line 6. I won't scribble anything. I want to show you. On line 6, I have shown you that from lines 2 all the way to where? Line 5. A lady asked that question in class. Now it's clear to us. The line we are working on is line 6. Okay. So it cannot be part of our narration of how we got to line 6. It will have to be about the preceding lines. We are talking about what has happened to result in the line 6. Okay, so we'll say that look at all the things that have happened from line 2. In this our example, it's not every time that I have to start from line 2. I hope a few of you who may be confused will look out for that. Don't always go and say from line 2 to something, because maybe in the actual work we'll give you, the assumption started on line 4. Then it means you will have to go and do your discharging from that line 4 where you did the assumption. For this our instance, it is from line 2. So we go to line 2 and say, do not do what you did from lines 2 all the way to, why not line 6? It shouldn't be up to line 6, for example, because we are now showing you what we have done to achieve the product on line 6. So it is something we did in the preceding lines that has resulted in the line 6. So we'll say from lines 2 all the way to line 5. What happened there? It is what? Indirect proof. This time, you see that I brought the number before. We have to be consistent. If you are doing the line before the how do I even put it? Before the value you have placed there, whether you have done conjunction, the operation you have done there, then it has to be consistently so throughout. We're going to do an actual one. I just want to remind you of the cases to look out for. So indirect proof from lines 2 or to 5, they would have been consistent with the earlier ones. So watch, we will mark this as well. Then now that you have shown us that we should not have negated not P as we did earlier, then we are ready to tell everybody what we should have done actually, which is what now, which is now line 7. And that says, see that line 7 is not part of what you are discharging. It is now standing on its own. It's part of the argumentation. Look at together again, you see. So line 7 now becomes the not P, the originally given conclusion, which you arrive at by what? Double negation, DN on line 6. Now let me make sure that you got it from the top there. Watch. You were originally given P conditional K when you were asked to prove therefore not P. I said this is a case study, it's not an actuality, because our concern is to look out for some key things that you are expected to have when you are doing indirect proof. We are only reminding ourselves. So we have to make sure that our given conclusion is what has been negated here. So in fact, the real thing to mark is line 2. Watch. Not P is what you have negated. How did you get the not P? You went to look at your not P, which is the given conclusion, and negated it to have not P. May I just ask an obvious answer, question for an obvious answer? What if the original conclusion was P? Then what will your negation be? Anyways, are you there?
Yes, please.
If your original formula, the conclusion was P, then I want a chorus answer, don't worry. What would have been the negation of that P, which you will work with?
Not
It will be what?
P.
Not P.
Not P.
No,
Very good.
not P.
Okay, not P. What if
Not
your
P.
original, yes, please. What if the original conclusion was P conditional Q? What will you negate? When you negate, what will it read as?
Not P conditional
Not
Q.
P conditional.
If you say not P conditional Q, it's ambiguous. So it could
Not
be
P.
Not
Into
P.
bracket.
so
So
not
P
open bracket. Can you see
conditional.
that? Not then open bracket, the P conditional Q.
Yeah.
Look on my screen,
People
I'll
are
show
saying
you.
only P.
Everyone listen. If the conclusion, look towards the left side of your screen. I'm writing something there. Let me use another ink now. In green. Hey, is that green? Hey, is it purple? So imagine the conclusion was this P conditional Q. Okay, everyone watch. Then you are to work with it by indirect proof. The next line where you are going to negate, it will be what? all of that into bracket negated. Yes. Yes. So this is read as not open bracket, P conditional, Q bracket close. That's how you read it. If you say not P conditional, someone may write this to work with it. Will it be correct? No. The two are not the same formulas. I hope you can see that. I hope you can see that now. Okay. What formula is the first one? One. What formula is that? Which compound is that? That's what I mean. I want chorus answers, my dear friends.
Conditional.
Conditional.
No, this one. The first one.
Negated conditional.
So it's a
Negated
negated
conditional.
condition.
Negated
Well
conditional.
done.
It's a
How about
negated
this one?
conditional.
And then this example 2 is which one?
Material implication.
Conditional.
Oh, which formula is it? You
Material
understand?
implication.
Which formula?
Conditional.
Material implication is
It's
a formula.
Conditional.
It's a
Conditional.
conditional. Very good. Very good. So this second one is a conditional whose antecedent is negated. The master of this house is called a conditional. The earlier one, the master of the house is a negation. A negation is not a conditional. Okay, so if we gave you originally, therefore, P conditional Q like this, and you have to work with indirect proof, when you negate to work with, your negated compound will be not open bracket, P conditional Q bracket close. Then you do everything that we have done all the way to your discharging, and then now affirming the originally given conclusion, which is what? Not P. I want to open a fresh page. Let me see quickly. Now on your screen. So let's work with substantive content. I will write it out. Later on, we'll start projecting from our workbook, which I've downloaded. Well, I think we can do. So still on indirect proof, then we'll go to then you'll be all ready to apply. Learn all the rules. Don't give any special attention to some. What's the other one? Constructive dilemma. If I have PQRS, everyone watch. If I have this, by constructive dilemma in the same order, what would the next premise be? You know what this is. I'm not putting in the variables. Okay, let me do it. If I have this, this is first premise. If I have this by constructive dilemma, what can I prove? What's the second premise, and then what will be the conclusion by constructive dilemma? Please don't waste too much time.
P disjunction R.
P or R.
I know, but we don't have time. It's an online class.
P
So the next premise is P disjunction R. Therefore, we can prove what? Therefore, we can prove. Very good. Don't forget them all. Don't forget them. Therefore, we can say Q disjunction S. So sometimes you won't even have the bound like you see in premise 1. Sometimes you may have, so let's go up a bit and see what we can do with this quickly. Sometimes you can have this. Look on my screen, please. You may have line 1, and it has P
Madam, please, I'm
disjunction
not
Q.
getting it.
Okay.
You can't see your screen.
Don't worry. No. We are not saying anything. We are just reminding ourselves of the rules of inference, which you must know.
Oh,
You understand?
okay.
Yes.
Yes.
Yes, it's just the rules, constructive dilemma. I'm just showing you how you can somersault and twist and turn and do salsa with with the rules. Exportation, we have revised. This is not the time to be doing that, but just so that once in a while, when people forget it, then you help them remember that it can work here. That's what I'm doing. Okay, so you have to know your rules. As for the rules, you must know them. So look at this. If we have, sometimes you won't have it on one row like that. I want to show you. You will have, let's say, for example, 2, 3, 4. So you have P conditional Q. Everyone keep watching. And you have R conditional S. Okay. If you have this, and then let's say you are to prove, this is too easy, but sometimes it's in the middle of about 10 different lines. Your ability to fish it out is the issue. You should be able to tell that this fish was fried and that one was grilled and this one was baked. It is a skill. If you don't practice it, you won't know whether the fish, someone can taste and say, we are here. Another person said, yeah, tutu. No one said, no, it is toasted. It's not fried and it's not grilled and it's not toasted, it's roasted. It's a skill. If you haven't practiced, you won't know. If you practice too, you need to keep doing it. Otherwise, after a while, your face will burn. Now we want to continue. Okay, so look, please, everyone look. Now, I'm saying you may be asked to prove Q, please watch, or S. Someone may now go and do material implication. Yes.
Doc,
Dog,
please,
we can.
This one is
Madam.
not coming.
I can't see your solution on my screen.
My screen.
Yes.
You can't see my screen. Which part of the screen?
Yes.
Oh, I've stopped sharing. Oh, apologies. I stopped sharing. Hey, Rade, they'll beat me up. No. It's okay. I stopped sharing. That's why. You should see now. Hey, can you see now? All this about meow.
Yes, please. Thank you.
Can you see binomialism now? Digitalization. Digital.
Yes, please.
Okay. So let's continue, friends. I was just saying that. Look, now we don't have it on row like P conditional Q into bracket or conjunction R conditional S. We don't, but it is still the same because conjunction, remember, when you simplify a conjunction, watch, if this was originally this, and I want to simplify. Can anyone see my screen, please?
Yes, please.
Yes, please.
Okay, it's fine. So, my dear brother, my gentleman who cannot see, can you give yourself some few minutes? You should see it. Okay. Now, please, everyone, keep looking. I'm saying that if I originally had line 1 like this, and it is a conjunction, we know what conjunction says. We can simplify one of the alternative conjuncts, isn't it? Isn't it?
Yes, please.
So if we
Yeah.
were simplifying line 1, we could have P conditional Q as one of our conjuncts, or R conditional S as one of our conjuncts. Is it okay?
Yes, please.
Very good. So when we
Madam, please.
Mhm.
Madam,
My
please.
brother,
You cannot see your
yes.
screen.
Oh, please. The screen hasn't gone anywhere. It's there. Let me stop sharing and reshare again for those who still can see. When you said you couldn't see earlier, it was only because I had stopped sharing when I was changing the slide. Okay, I'm going to reshare again. Where is it? There's something I want to show you because I think those are the things that get at people. So I've stopped sharing now. And I'm going to reshare again. So I'm resharing and everyone should keep looking. I have started resharing again. You should see it if your network is okay. Okay. Can you see now, please?
Yes, please.
All right. So let's continue.
Madam, it's clear now.
Oh, my lady, please. Anyone who cannot see now should just be patient. It can't be me. Do the deduction. It can't be me. Okay. Look at me. So let's
I cannot
I mean, I are laughing at me. Yes, I say it's your network. I don't want to say it into the recording. People will laugh at you. So give yourself just a little bit more time. Okay. As soon as some can see, we are 240 something now. It's a big class, relatively. Okay. As soon as some can see, it just means be patient. The young two shall go. I'm trying to show you something that I don't want us to miss. So keep your focus. I'm saying that it is something that gets at people. And only it does them surya when they are doing deductive logic. What is it? They don't see Please look on your screen. Often they don't see that when I have line 1, thankfully it comes as a conjunction, which I am now going to simplify one of the alternatives to get it as what? 1 and 2. It's not always the case. Sometimes you can have it as a straightforward. So let's rewrite the same thing again. Watch. So P conditional Q. All of that conjunction R conditional S. These are 4 different variables. The left conjunct is a conditional, the right conjunct is also a conditional. Now this thing you see here could have been simplified. So look, could have just been this. Keep watching. We could have had it this way. Line 2. Could have had it this way. Then line 2 will be R conditional S. It is still the first premise of what? Constructive dilemma that I have put there. I have just simplified it. I've taken the other half and put it as another line. So in your mind's eye, you should see this P conditional Q or conjunction R conditional S. And then you know that if I had this as my first premise, what is the rule if I'm doing constructive dilemma? The husbands will be together with a disjunction. The wives will be together with a disjunction. So the second premise could be P or R. Therefore, I can deduce or derive R. Yes, excuse me. What can I derive, everyone?
Q or
By
S.
constructive dilemma.
Or S.
Very good. Very good. Q or S. You see that? This one we have just done at your right side, circled in red like this. This one is the same thing we'll be doing at our left. Keep looking on your screen. Suppose I gave you 1 and 2. By constructive dilemma, you can say, hey, 1 and 2. Then I have 3. That is what I was doing before we went up. Then I gave you P or R. You can conclude or derive 4, which is what? Everyone.
Q or
Q
S.
or S.
Q or S.
I can conclude what? Q or S. You see that,
Q or
please?
S.
Yes. You can get Q or S by what? Constructive dilemma on which lines? 1, 2, and 3. If you are looking at my left side formula, which is in green, yellow, this one, you're looking at this, and you were doing a derivation. You have line 1, you have line 2. You could come by line 3, and then from that deduce what? Line 4. How did you do it? By constructive dilemma on which lines? On line 1, 2, and what? And 3. I hope you understand how that happened.
Yes, please.
Very good.
Yes, please.
I know my people are that busy. They don't like shouting when they are outside or when they are online. So it's fine. I know you get it. So at your right side, the right side formula in red, we would have said, oh, we arrived at line 3 by constructive dilemma, same. But this time it would have been on lines what and what? Everyone.
1, 2, and 3.
There wouldn't be a 3.
1
Look at
and
it very
2.
well. Would have been on lines 1 and 2. Why?
1
Because
and
we married.
2.
Look at what we did at line 1. Just so you see, both of them are constructive dilemma. Like the yellow box, or we just stir the ground. We just shade the groundnut before doing the groundnut paste. So we had an extra process, which is line 2. But when you look at the right one, she put everything inside. And added the steamed meat and everything. And allowed it to cook for a longer time. And the groundnut soup cooked perfectly. We still came by the conclusion Q or S, Q or S. So one had a shorter process, the other one had a longer process, but they are still applying the same thing, constructive dilemma. Why? Because of the simplification. I need you to see these tricks. Now let's see something else. with the rules, which gets a student when they are working. Suppose I gave you P conditional Q or disjunction R. Do you realize that this, oh no, let's use a conjunction at the other side as well. So the reason, is that the reason? Oh. Hey, Baumia, Digita, do the do. Excuse me. I said, now critical. Hey, Ghana for Munyo. Yes, Digita. Okay, Afa. Watch everyone. Suppose I had this P or Q or an R. What will be the replacement of this by distribution? How I wish I could see everyone do it. Do it at home. The way we do it in class. We are just revising these. Then I will continue with the exact examples on indirect. We'll do it together.
Conjunction Q this R.
Who is speaking now? Let me check. I want to give you a mark. Okay, 27 people went out. Where were they before they went out? By distribution. Well done. It's like what you call expansion in maths. It will be what?
So
this is Salima or Insia. Who is speaking?
Madam Harry.
I want your surname. I see a surname. Is this Salima?
No, please. Osebonsu.
Osebonsu. My lady, go ahead.
Madam, so it's going to be P conjunction R.
Very good.
Then
I'm sure that someone is saying, is this girl or this lady saying, watch.
Madam, please don't
this
forget
junction and
my
conjunction.
marks too.
I won't. My tears are on standby. Say. They say it's on. That's why I mentioned his name. Everyone will hear. Why this red pen is bigger than the one that EC is using to do the collation. We will write it down. Don't worry. Okay. Now, everyone watch. If you have this can be distributed. It can be. I need you to see that. So the replacement rules, they go forward and they come backwards. That means if I have P conditional K, which is your friend, I know you love material implication. It is the same as what? Not P disjunction Q. Okay, these two are the same, which means if I am moving from the conditional to arrive at the disjunction in this way, that's the forward movement. That's fine. I could also move from the disjunction to the conditional. That is the one that gets at people when they are doing the inverse, the reverse version. Okay? And I'm helping you remember because we have done all that. Okay? So if I have this, Madam says this formula can be rewritten correctly by its replacement rule. The value is the same. Remember, I gave you 50 Ghana CD notes. If you remember already, it's a good sign. If you say, oh, dog, this one, you said it's so remember, it is good for you. The one that is now cementing it is welcome news for him or her as well. Okay, and I'm the one saying quite. So let's keep reminding ourselves. This one is the same as Madam says P. Sister, continue. You said P conjunction R. Or what did I write next? My lady, what did I write next?
Madam, it's supposed to be P.
Don't worry, don't correct this one.
P conjunction R. Okay, so the next
P
one.
conjunction R and R conjunction P. Yes, by distribution.
Yes.
That's what you can do with this. Let me help someone quickly, then we continue. Because conjunction is commutative. Someone may start by saying R conjunction P. You have not said anything different. When you come to predicate logic, of course, we open it out and show that sometimes we might be saying something different when we are dealing with actual language. She got pregnant and got married. It's not the same as she got married and got pregnant. That's what we know. What would you predicate? Okay, even though they are both conjunctions, it seems as if you do the pregnancy before the marriage, it connotes something different than if you do the marriage before you do the pregnancy. That's fine. We'll do predicate logic. But at this stage, P conjunction R there, and then R conjunction P. There's no difference. By commutation, by the rule of commutation, they are not different. So, madam, let's continue. What else do we are expanding? We are doing distribution, distributing over the bracket. That's what we are doing. So, what should we say next? Please go ahead, sister. Sister was answering the question for a mark. Yeah, there are several hands up. I'm not calling apologies. Catherine, do you want to do that? Just that to go and look for Catherine and give a mark will mean I'll have about 20 Catherines. I won't know who to give the mark to. But you go ahead. Obey, your hand is up. Obey, do you want to continue? Please go ahead.
Yes, please. So a conjunction, then bracket open. Sorry, a disjunction, then bracket open.
Good.
Please, I'm continuing for her.
Please do. So you want me to write a disjunction? Everyone see what is happening when you are doing the inverse of distribution. If it's the forward one, it's easy. We all know. You do it like the way you do expansion and math. But it is the inverse that creates problems for people. They don't see it when they are decomposing or deriving. You don't see that we could change the first formula to the second by distribution. They don't see it. Okay, but we are looking at what see. So continue now. We know we'll have a bracket at the end.
Bracket open.
Yes, please. Yes.
Q conjunction R.
Excellent. Q conjunction R. You will see that the main conjunction is what is in the brackets. Everyone watch. That is what the main connective is when you expand it. And then the one that's the connective with the isolated brother, the Matemeho group, those that have the separatist group, that connective is the one that goes into the bracket where you expand it. What? So it would have been R and Q or R and P. That is what has been expanded to the right. That's all. If you see this and then you were asked whatever you are decomposing, suppose you had this side of the formula. Everyone keep watching. Don't lose track. Oh, where is it? I keep switching of this marker. Okay. So if this was maybe the formula they said derive or prove is R, but the formulas given to you as premises have P conjunction R and Q conjunction, this kind of big complex formula. You just have to do the reverse and it will generate this formula. That will be your first step. Then you simplify the R. 3 steps, you are done. The way you use air fryer to do the fish fast. Or need fufu in the kitchen, warm water, you put inside chim. By the time the people go and buy cassava and come from the market, your fufu is ready and your life soup. You have saved the marriage. You see, 3 steps. If you know the inverse of this, someone will now be going to change this to material implication by disjunction, negate the antecedent, and then now come and somersault and that means you go through the whole process of doing the palm nut soup before you get the juice, go and throw the chaff, come and clean up the oil. Peel cassava, they're looking for a goat to give the peels to. When someone has finished, trimmed her nails, washed them, always laughing at me. Has trimmed the nails and is watching TV, has set doing dessert and what have you. You have to know the rules, both forward wise and backward wise. Okay. So the inverse and then the forward. I think that enough of the revision of the rules. Back to our indirect proof with specific examples. And I want to now share your workbook. Everyone keep watching. I want to applaud the class. You're very comported. Attendance is very good. I presume people are active. In fact, people slip out and they are anxiously coming, poking at me, dog, please, I slip, get me back in. It's a good sign. Let it count, okay? You do your tutorials as well. Your TAs are working hard to help you. You should be able to get a straight A by a dint of hard work. All right, now I want to show you your workbook, which you all have already. I just want us to pull some sense from there and work on it. We'll be there shortly. So let's project that. Keep looking on your screen, please. Now, this is your workbook. Let's make sure we have covered content that you can be accountable for. So there are things you should have learned from your PHCL 204. Let's see if we are able to write on this. Where is it? Yeah. So if you look at your PHCL, I could give you, oh, where is it? I could give you P conditional Q or disjunction R biconditional not S together. Keep looking on your screen, please. Then let's say I did it conjunction not S. Okay, so we have PQ. Which formula is this? I want a chorus answer. I want the name of this big compound. How will you call this compound?
Junction.
Conjunction.
Conjunction. Very good. Conjunction. At this stage, if you don't know which compound we have, that is a different sickness. It's not something you cannot cure. Just that we need parazole to help you cure that one. Okay, because then there's a bit of level 200. There's a bit of this semester to cover. Okay, it's not impossible. Just that you will have to fill in a bit more. So this is a conjunction. Now, if I gave you the truth value, don't get confused with the plenty words. This is the value of truth. The value of truth is either true or false. That's all. So propositions have two values of truth. One of them pertains all the time. It can be both. That's the law of excluded middle. Remember, element of formal logic. You can't say it is this and at the same time the negation of that. So you can't say P and at the same time its negation. That's what we call the contradiction. It will go against the principle of non-contradiction and the law of identity and so on and so forth. Okay, so if I told you that P is true, everyone start working. This is what you can do in your worksheet and test yourself. It's good if someone is watching you, but it's better if you are watching yourself. Where is the thing? Good. So I want to go back to admit people who are out. A minute, I'll reproject. Where is the thing? Yeah, I know. Class you and stay inside. I can't be admitting you. Okay, there we go. So those who slipped out should be back in. Now, my dear friends, if you can see my screen, then I'm showing you something here. Watch. Suppose we say P is true and S is false. We should be able to tell the truth value of this whole compound that you have confidently told me is a conjunction. What will be the truth value of this compound?
It is false.
Slow down before don't say this. Have you finished working it? Or you can see
It is
from the
false.
realms.
No.
Some people went to look inside the realms, it didn't work. So
It is false.
please, yeah, sure. One work here. Have you worked it, brothers and sisters in the Lord? Yeah. Be careful. Don't go and see when God is showing you a TV3. They say you can see a. All right. Let's work it together and see. A lot of your friends say it's false. Do you have a contrary answer? Maybe people are saying false, but for different reasons. So let's work it. If I have a conjunction, this conjunction has two conjuncts. There is not S as one of its conjuncts, and then a disjunction as the right conjunct. That disjunction itself has a left disjunct that is a conditional, and a right disjunct that is a biconditional, with the right alternative of that biconditional being negation. Okay, so that's a full description of our formula. It's a conjunction. Now let's look at the value of S. S is F. It means S is false. If S is false, what happens to our not S, which is the left conjunct? It becomes what?
True.
Please, everyone respond. If S, the value S is false, then what happens to our not S? It is true, isn't it?
True.
Yes.
Okay, so our left conjunct is true. Watch what I'm doing. I have to get another marker so that you can see it clearly. I want to use a blue now. So see, the left conjunct, this is it. Don't do arrow when you are showing me. I want you to see. That's why I put it there. Not S, which is our left conjunct, is true. Will that be enough to tell us the truth value of the whole conjunction? Dear friends, can we stop at this stage and say that, oh, we know our left conjunct is true, therefore the whole conjunction is true? Can we? Or should we?
No.
No.
No, we shouldn't.
No.
Because, very good. Because just in case the right conjunct is false, our conjunction can still be false. I hope you get it. And just in case our our right conjunct is true, the whole compound will now be true. So we are unable to determine yet the truth value of our conjunction. Some people like to do shortcuts without having
We can't
substantive
see the
ground.
screen.
Oh dear. Which screen is this that you can't see?
The screen is blurred.
There is a time, please.
It's a
Everyone keep
blank.
quiet for me.
Okay. It's a
I
blank.
haven't projected anything yet, except what was there earlier. Okay. Now, let me just stop sharing. Reshare. Please focus on what I'm showing you to remind you of what we did in the weeks 1 and 2. Okay. Which is part of element of formal logic, but it is important for you for your preparation for the IE. Keep watching. I'll stop sharing and reshare again. Okay, let's do that. So I stop sharing. I've stopped sharing now. Let me reshare, and then I'm going to reshare. Can you see, please?
Oh, doc.
Yes,
Yes,
please.
please.
Yes, please.
So should we continue? What I'm projecting has a red ink writing of conjunction at the bottom. That is what I'm projecting now. Okay. Now I said that because we don't have enough justification, enough grounds to conclude that we know the truth value of our conjunction, we have to continue working. If this were a disjunction, we could have ended at just this stage and conclude by telling everyone that our disjunction is true. I hope you see why.
Yeah.
I
Please,
hope you
Yes,
see
no.
yes,
why.
though.
If it
Yes,
were
though.
a disjunction, all that a disjunction requires is one of its disjuncts being true. If you have one of the disjuncts being true, it is enough to make the whole disjunction true. This is element of formal logic lecture 2. Okay, so that if I have P disjunction Q and P is true, do I care whether Q is true or false? It won't matter. The whole disjunction will be what?
True.
True.
The whole disjunction will be true. Very good. Why? Because I said or, so I will come to class or I'll go to the market. If I told you I'll come to class or I'll go to the market, and you confirm that I went to class, but you can't tell whether I went to the market or not. It won't matter whether I went to the market or I didn't go. I said I'll come to class or I'll go to the market. And you have seen me in class. I fulfilled one of them is enough to make the whole disjunction true. So if you know that one of the disjuncts, that is if it were a disjunction, knowing that one of the disjuncts is true would have been enough to make the whole disjunction true. But lo and behold, the formula we are working with now is not a disjunction. This one is a conjunction. So let me clean the ones I put there. What we are working with now is a conjunction, not a disjunction. Look at the sign, this, it's conjunction. Maybe I clean it and write it again for you. your viewing. Everyone follow. You answer these questions and you should be able to answer it easily. I know that for a good number of you, this is a good revision, but you really don't need it. You are very fine with this from element. But I leave the 99, like I always tell you, and follow after the one to help them catch up. Okay? And it can be a revision for that's our conjunction. So now that we know from S alone being false, it tells us that not S is true. And not S is the left conjunct. So we have confirmed that the left conjunct, one of our conjuncts, is true. We can't stop working. We have to go further and see what is happening at the right conjunct to be able to tell whether the entire conjunction is true or false. You're only applying the rules there. Okay, so now we have to go here. Now at our right side, the main connective is a disjunction. We don't know the values of the others, but remember we know the value of S. So S is false. If S is false, I want another pen quickly. Okay, so if S is false, everyone keep watching. Then not S is what? I want a chorus answer, please. If you have a fine background.
True.
Then not S is true. Good job.
True.
Now, yeah, not S is true. You see that we are unable to tell what happens with R because we don't have anything to help us out. But we know that the right biconditional is what? True. Let's go to the left disjunct within our formula and see. If P is true, can we tell what is happening with Q?
Thank you.
Hey,
It will be
I don't
true.
know critical.
Oh.
So how did you get? Excuse me. Somebody say something. Say it and let me see. If you have a true antecedent, can you tell?
Then the
No.
consequence must necessarily be true
Why?
because it's a conditional, and with the conditional,
I have not given you the
when
truth value of the conditional. I've just given you the truth value
we
of
have
its
the P.
antecedent. Yes,
Yes, and with
but
the
if P is
conditional,
true, relax. If P, which is the antecedent, is true, it doesn't tell us anything about the conditional. If the antecedent is true and the consequent is false, then we will know that the conditional is what? All of us.
false.
False, okay? But if P is true, very good. But if P is true and the consequent is true, then the conditional will become what? True. You see that? So if we don't know the value of pill, can we tell what the value of our conditional is?
No.
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 You see? So here is
Madam,
here's a
can't we ask?
please hold on. You can't assume Auntie offer. Can you assume that a cheddar one? You get trouble. You can't assume. You have to work it. Okay. So this side of our disjunction is undecided. We are indeterminate. We can't determine because we don't have the resources to do so. We were not given that. Now let's try the right side. We're unable to do anything at the right side also because we have a biconditional whose right alternative is what? True. I hope you can see that. Not S is true. Is everyone following?
Yes, please.
Yes.
All right. Thank you very much. It's true. Can we therefore say that because
So
the right
please, what
alternative,
makes
which is the not S, is
true?
true, we should say that therefore the biconditional is true? Should we say that? No, we don't have the resources to. If it turns out that R is true, if R is true, then the biconditional will be true. But if R were false, the biconditional will become false. So it is indeterminate. We don't have resources to determine the right side of our disjunction. This whole thing, we don't have enough resources to determine it. So how did you people arrive at it? If you are easy, you are in trouble. How did you arrive at it will be false or true? This is indeterminate. We don't have resources to determine, okay, whether our formula is true or false. Now, I can rework it in a way that we would have been able to. Is someone calling me?
Yes, Dr. Nancy, I am having a
Who's
challenge
speaking?
with the indeterminate. Madam
Who
Emmanuel.
is? Hold on for a minute.
All right.
Which Emmanuel is this?
Emmanuel Sando.
Okay, go ahead. What is your question? Ask your question. We should accept
Madam,
that something is
my challenge is with
uh-huh.
the.
Go ahead.
Madam, my challenge is with the conclusion that it is indeterminate. Is it not?
What do you
Is
want?
it not
What?
the case?
Hold on for a minute. Hold on for a minute. Okay, then you can ask your question. Okay, what is the challenge you have with it? I'm asking you to tell me the truth value of the given formula. What is its true value? Is it true? Say. No, is it true? We are trying to work our way out
Madam,
of it. Oh,
okay,
Johnny Bravo. Is it true?
but
Yes or no?
Doc,
Emmanuel, is it true?
Doc, the challenge I am having
Is it
with the
true?
queue.
I'm not asking for your challenge. Can you hear me? Is it true?
Yes, please.
Is the
It is
formula
not
true?
true.
Okay. Is it false? Is the formula false?
Madam, to me, like it will be true.
Sir,
That is the challenge I am having
I
now.
don't want explanation yet. I want to help you. Give me the resources you have. So I'm asking you, is it true? You say no. Is it false,
Yes.
sir?
Madam, yes,
Is it
to me it is
false?
true. It is not
Okay, you think it is
false, but
true?
it is
Hold
true.
on. Okay, you
Yes.
think it's true. Let's check. Maybe we didn't work it well. So everyone watch. Let's go back. If you had such a formula, the formula is not S conjunction, open square bracket, open bracket, P conditional Q, bracket close, or disjunction, open bracket, R by conditional, not S, bracket close, square bracket close. That's the formula given. Then we were given
Yes.
information about two of the atomic formulas. We're given S, the variable S to be false, and the variable P for Paul to be true. That's all we're given. And we're told, tell us the truth value of this formula, which is the conjunction we have been given. Emmanuel, are you following?
Yes, Doc.
Okay. Now you have S to be false. When you negate the S, which is what is in the formula is a negated S, but the variable you're giving was S. So negated S will be what? Say, in terms of value, what will it be?
Negated S will be false.
Why false?
Right.
If your S is false, negated S is what?
It's true. It's true.
Don't let anybody tell you to say true. I would have brushed you aside and gone if I wanted to do that.
Yes.
I want you to
Yes,
understand
Doc.
so that your confusion will be gone. You understand? That's why I'm taking you
Yes,
through.
Doc.
A lot of your colleagues, I'm
Yeah.
sure, get it. So if your original
Okay.
S is false, then its negation must be true. It's not a choice you have. Okay. So that is what we have as a blue. Okay. So we know the left conjunct. This whole big conjunction has a left conjunct and a right conjunct. Now the left conjunct, we know its value. It is true. Please, do you understand that one too? There.
Yes, please.
Okay. Now we go to the right conjunct. Why are we going to the right conjunct? Because I want to mute all, and then our friend can unmute. I want to see somebody's background is very noisy. It's breaking my ears. So I will mute all, and then if it is Emmanuel, then he will have to unmute because we are working on his case. We want to make sure that he's fine. If it is him, we can manage it until he's clear in his mind. Let's what say. Okay. So I'm saying that now to the right. We need to finish up the right side. We can't gloss over it because we don't have enough resources yet. So we go to the right. The right to which compound are we dealing with? It's a bit mixed up, but you can still see. Which compound is it? It is a disjunction. Emmanuel, can you see? It is this one.
Yes, please.
Oh, very good. Now, what is the rule for a disjunction? Disjunctions are like either or statement. So if I make an either or
Yes.
statement, the only time that statement will be false is when none of the alternatives I've given come true. I've given you two alternatives. Either I am in class or I am at church. You go to class, I'm not there. You go to church, I'm not there. Then what I said is false because both both disjuncts are false. But if I say I'm in class or at church, you go to church, I am there. Come to class, I am not there. One of the alternatives has happened. It is enough to make the whole disjunction true. Please, you understand that one too? Sorry, sir. Do you understand that one too, please? Oh, my friend says he doesn't agree. I'm trying to help him. Is he gone? Emmanuel, are you there? Okay. When Emmanuel comes, I'll continue with him over there. But my dear friend, so Emmanuel, are you there? You are back. Emmanuel. Emmanuel,
Yes,
do you
please.
hear
But
me?
I was having
Very
a
good.
challenge with my network.
No, it's fine. We waited for you.
Yes,
So
please. I
what?
can hear you now.
Thank you, sir. Thank you. Now what? So we are trying to make sure that we can at least make one of the disjuncts. Your focus now is on the right side of the conjunction. I hope focus on it because the left, we are done with it. We know the truth value for the left side, the left conjunct, the main connective, this one. We know the truth value for this. We are trying to work out this side. Here too, if we are even able to establish the truth of one of the disjuncts, this is one disjunct, this is another disjunct. If we are able to establish the truth of one of them, it will be enough to hold the whole disjunction. Okay, that's what we are doing. Emmanuel, are you there? Is Emmanuel there?
Doc, I'm here. I can hear you.
Great. Okay, so I'm continuing. So that's what we are going to work now. What resources were we given? We don't choose the truth values of the formula. We have been given. So the instruction says, I am giving you the value of P. P, take P to be true. Don't decide what you want to take. Take it as true. We don't know the value of Q, do we? No, we're not given. Do we know the value of R? No, we're not given. Thankfully, we know the value of not S. We can work it from the S that we were given. So S was false on your screen now. So by that, we can know not S, which is the main formula here. Not S is what? True. So we are working with the true. Is it okay, sir?
Yes, Doc. Doc, I understand now. I was thinking that because there's
Dear,
no
don't,
negation.
Dabi. Let me finish, okay? So now that we know not S, we should have been able to work with that, my dear friend, to help us find the truth value of the biconditional. But we are unable to tell what to do with the biconditional, how to interpret the biconditional, because we don't know R. If R's value is true, then our biconditional will be true. But R's value could be false. If R's value is false, biconditional says we can't have one person being true, the other alternative being false. The whole thing. So the value of R is crucial for us to be able to interpret the biconditional. We cannot do that at the right disjunct. Okay, so we give that one away and come to the left disjunct to see if that one gives us any hope. There too, we are giving only P, which is the antecedent, to be true. If the antecedent were false, we could interpret the conditional. It's enough. A false antecedent means the whole conditional is true. Make me president and I reduce fuel. If you haven't made me president, I can still walk around saying that I would have maintained the fuel prices or decreased it. You see, a false antecedent means we are not able to test the condition. So it will remain true until proven guilty. We have done all that. An element of formal logic. Okay. Maybe you are reciting, I don't know. So sorry, or maybe you forgot something. So we are working it out. Okay. Dear friends. So here again, we don't have enough to interpret our condition. And we need either one of them to be true before the whole formula will be true. If the whole thing is false, it will make our conjunction false. So we are unable to tell what the truth value of the conjunction is. That's what I meant when I said it's indeterminate. We are unable to determine. It's not true and it's not false. Why? Because we don't have the resources to do that. What we were given is not enough. And that can be a question that you are asked. Determine the truth value of the formula below. You work it and show that since you are unable to tell the truth value of the disjunction, which is one of the conjuncts, then the value of the whole conjunct is indeterminate. Indeterminate means I don't have enough resources. Good. Well done. I think Sir Emmanuel says he's fine. I just mopped up so that we are clear in our minds. We can now go on to our final revisions using
Thank you, Doc.
exact examples. You are most welcome, sir, in the workbook. Okay, so we are going to the workbook now, which I have projected already. Unless someone has a question, then I'm glad to take that question. If not, then we can move on. So please, dear friends, look at, you are supposed to know this and others when you are given rules, formulas with assumed values, and you are asked to work the whole value. You should be able to, without doing true, true, false, false, true, false. No. You should be able to assign the values and then determine the value of the whole thing. Then you did some of the natural deduction questions with my colleague, which is what we are now formalizing with symbols, okay? Sentential logic proofs. Keep looking on our screen so you know that we are working with direct proof. What are we doing now? What am I doing with you now? Revising, mopping up, filling in gaps. As we go on, if you notice that, hey, this particular thing, I didn't think that I have learned to do, then it helps you know what to go and revise. Obey, your hand is up. Was it to address a question or you are asking one?
Yeah, Doc, please, I have a question.
Oh, sorry about that. I just saw it. Go ahead.
Okay. So pertaining to what we were doing, I understand the true of or finding the truth value of it. So
Yes,
please, in case they ask such questions, how are we going to go about
the
it?
day is the
Like the
person
procedure.
talking to you. The day is the person talking to you and her colleague. We can ask you that. You know, oftentimes we wouldn't want to, but it can be that. Just to see if you understand the truth conditions of the various compounds you've studied. This is element of formal logic, really. Okay. So if you were asked that, you will be giving values. You work it to show and tell us that, oh, that compound you give, maybe I give you a biconditional or a conjunction or a disjunction or a negation, it is true. Either it is true or it is false. But sometimes it could also be indeterminate. You don't have enough from what was given to you to tell whether it is true or false. Then your answer is it is indeterminate, or you don't have enough resources to tell whether it is true or false. That means you understand the rules and you understand the connectives and its application. Okay. So that is simply it. The day who asks you the questions are the people sitting here, myself and my colleague. Obeng, is that okay? Right. Let's continue. I mean, it's when we get to a certain time, you will tell me that, Doc, this one we can't tell whether it's true or false. Like some of the instances in class when we are doing our derivations, you see that you derive, how derive, the thing is not deriving. Then you say, me, I can't do it. Where is Esther? Is Esther here? Esther will say, Doc, me, I can't do that. I say, Esther, you can't do this. I don't see. We'll go to the board. The thing should have been conjunction or disjunction. We have put the opposite. So it's difficult to decompose or derive. Okay. They are proofs. So if you can't find whether it's true or false, when you are applying the rules correctly, not when you don't know the rules, but you're applying the rules, you have done the negation of it, you have somersaulted, you have done everything, it is still not coming. Then perhaps you don't have enough resources from what is given, from what is assigned, to be able to determine whether it's true. That's all. That's the answer we'll be looking for from you. Okay. Right. Back to our screen. Oh, Juanani. Back to our screen now. Okay. So you know that you are doing direct proof, you are doing conditional proof, you are doing indirect proof, which is also called reductio ad absurdum. And that is page 6 of your 64 page reader. Can I move on? Unless you have a question on that page. I want to move on now. Then we got to the rules of replacement. Is everyone watching? Let's all mention the rules so that they will love us and we will love them as well. What's the first rule you see on your screen that I'm projecting? Everyone do some.
Morgan.
Okay?
More than
Morgan. Very good. Well done. Well done.
Commutation.
So much. The rest I won't ask you again. You are doing another. Okay. I've muted everyone. So we know we can move forward and we can move backwards. And the Morgan is not tough for a lot of you, I think. From my assessment of the class, I think you're very conversant with that. So we can move on. But we also know that the next rule is, so let me help you out. There's commutation. We have used it a lot. Look at association. check the rule for association. Don't go distributing when you're doing association. Please watch my screen. I'm going to show you something. Something people don't often see. Look, where is it? See, association, see the rule, see the connective. Is disjunction, disjunction. That becomes disjunction, disjunction. It's the same connective running throughout on both sides of the equation. But the variables are three. Variables are the P, Q, R, S. They are P, Q, and R. But the connective, the operative sign, the constant is the same. Okay. So where you are dealing with a conjunction, see, you see, it's PQR becoming PQR. Conjunction, conjunction to the left. When it comes to the right, still conjunction, conjunction. What changes is the bracket only. So you are moving from maybe the first two brackets to the last two brackets, or from the last two brackets variables, last two variables to the first two variables. It's just the bracket that changes when you are doing association. Don't forget. It is not the same as distribution. I'm not distributing. Now, just after that, look at line 4, formula 4. That is where you distribute. See, distribution operates on two different connectives. The one outside with the separatist group, group, versus the one inside. But the variables are still three. So you expand it into two sets to your right. We have worked on that already. So it's just a good reminder for you. Transposition, also called contrapositive. In this course, I mean, we use contrapositive more for uniformity. We use the conjunction, the dot, more for uniformity. You are not obliged to use the other, just that it helps to be part of the collective for easy referencing and things. So you know contrapositive, you know double negation. I want to move on. These are all replacement rules. The value is the same, sort of. I can give you that one to your left and collect the one to your right. The way we change money. These are replacement rules. They are not implicational rules. They are not rules of inference. You know all this already. Just important that you revise them for your interim assessment. I'll ask you MCQs. I'll do some short answers. You work the equations so that we are sure you have covered grounds all in about 30 to 40 minutes. I'm still settling on that. You will work in class next week, God willing. Okay. Now, material implication, you know, so I'm not going to belabor the point. Then material equivalence. You will notice that we haven't used those also too often, but it is still the same thing we know. The P and Q are either true together. Where is it? So P and Q, or we are doing equivalence now, this one, material equivalence, or not P and not Q. Oh dear, where is it? Oh, and not Q. Where should I write it? Can you see? They are either true together, this one, or false together. If you remember, when we were doing true, true, false, false. If I have an equivalence, if I have P by conditional Q, I'm saying that if it's the P by conditional Q is like saying, I will pass if and only if I study. Okay, that means if you see that I passed, you can conclude that I studied. Or if you see that I am studying, then you can conclude that I have passed. So that is what you say, P then Q, or Q then P. Very simple. This is correct interpretation of P by conditional Q. This is also correct interpretation of P by conditional Q. They are all expressing the material equivalence. Doc, what have you done so far? I'm just helping you remember the use of the rules because your workbook wants you to know that as you do your derivations, whether with direct proof, indirect proof, or conditional proof. That is what we have just done, okay? Helping you remember. So material equivalence is either the two variables are true together, or this is what I'm quoting now, true together or false together. Another way of saying the same thing is saying if P happens, then Q will follow. Oh, this shouldn't be all. And if, where is it? This should be end. And if Q happens, then P will follow. So the arrow goes this way. If P, then Q. And If Q, then P. You see that it goes both ways, so it's and. When you use the conditional, the middle is conjunction. Okay, let's move on. That's what you see there. Where is it? Material equivalence. So line 8. P by conditional y is the same as if x, then y, and if y, then x. That's one of the interpretations. This one. Or x and y. Where is it? Hey, this is the one down here. And okay. Then the second one is s and y, or not x and not y. The one at the top. Remember the way I make them simple for you. They are either true together or false together. That is this one. True together, P and Q, or false together, not P and not Q. That's the first one. Or if P, then Q, and if Q, then P. That's the second one. That's the material equivalence. Okay. You know exportation, we did it in class. You know tautology. The last time, one derivation we did in class, the rule that we were struggling with was what? The tautology. We didn't realize that P or P is the same as P, which is the same as P and P. So if I have P and P, I can say P. If I have P or P, I can still say P by tautology. Oftentimes it evades us. It's a good reminder. Then now the rules of inference, and then we can mop up our last two proofs and go home. Okay. Modus ponens, modus tollens, I think those ones, you know them very well. We revise constructive dilemma for the benefit of someone who still wants to see, oh, where is it? Constructive dilemma. There it is on your screen. Look at it very well. Let's use a red now. This is constructive dilemma. You see, P then Q and R then S. 4 different variables. Conditionals at both sides, joined together with a conjunction. You have done that. Then you affirm, or if you like, your next premise establishes the antecedents. It can lead to the consequent, or maybe you do the consequent, it can help you derive the antecedents by constructive dilemma. It looks very complex. It is not. You have to see it. It can save you a lot of stress when you are working. Okay, if you know that rule. Modus ponens and tollens, I think, is straightforward. Let's see, you know hypothetical syllogism, P then Q, Q then R. Watch. This could have been, please watch. I want to show you the one that escapes you. Q then P. Keep watching. Then I have P then R. What will be the conclusion by hypothetical syllogism? Everyone, I want a chorus answer, please. Q then P. Next premise P then R. What will
Q
be the
then
conclusion?
R.
Very good. I had only one lady's voice.
Q
Q then R. Okay.
Q
Not Q and
conditional
R.
R.
Q conditional R or Q then R. All you have to
Q
notice is this.
conditional
This
R.
is the intersection. Okay. I'm still entity. I'm still going to do another hypothetical syllogism. Please keep watching. I'm going to do another hypothetical syllogism. Don't lose track.
Doesn't make sense.
R then S. Antia. Johnny Bravo. Watch. R then K. Watch, oh, keep watching. Then S, then R. Therefore, hey, baby. It's
S
correct.
and
Therefore,
S then
K
K.
then S.
hey, Antia,
S
S then
conditional
Q.
Q.
K then
Therefore,
this
K
S.
is,
conditional.
it has to be
S
therefore
conditional Q.
S. Keep watching. S conditional K. I brought it for a reason. The S is at the antecedent position. So, Sister Adua, don't let him keep calling you. Listen to me, okay? Now, the S is the antecedent. So it is the S. How do you know that? Look at the conditional sign. R and S are at antecedent positions. K and R are at consequent positions. When you find a common factor, you cross it out. It is the antecedent you affirm. See, you bring first. So S must come conditional K. Oftentimes, people say what one of you said. People would rather say K conditional S. It's not the one who comes first at the top. It's the one who comes first in terms of antecedent that you bring first. So it should be this and not this. I'm happy with it, this one. So that is hypothetical syllogism. in its various versions. Simplification, you are very conversant with it. Addition, some have still not come to terms with it, can be very useful in your derivations. Addition. Because sometimes the variable they've given you to conclude or prove, it is not even in the resources given to you as premises. Okay? They're given. It's not there. But you have some atomic formula or some compound standing somewhere that you can, add to bring in the raw material you don't have. Okay, so addition can be very useful in that regard. You don't add with a conjunction. Don't forget it. You add with a disjunction. In other words, you can't say, I have P, therefore I'm going to say P conjunction R and write there addition. It is not true, it's a lie. You are fidgeting with the figures. Okay, so I think that is also a good reminder. What about absorption? Where is it? Absorption looks like exportation a little. I think we dealt with it in class. Where is it? This one. Let me use a yellow marker now. Everyone keep watching. I'll change our marker so you can distinguish it. So this is absorption. The one in the box in yellow. It is not a replacement rule, brothers and sisters in the Lord. It is an implicational rule, a rule of inference. If you gave me the premise, I can produce the conclusion out of it. It's a raw material that can yield something else. Okay. So if I have P conditional Q, absorption just says, repeat yourself. See how we symbolize it. A, B, S. Okay. You can conclude the P, which is the antecedent given. Keep watching my screen. This one. Conditional, as if you are going to write the same thing that was given to you in the premise. The premise is this. So you write your P conditional, but then instead of going to write the Q, you repeat the P itself again, bring the conjunction, and then now bring the Q that was given. That's all. That's absorption. So it's long talk. The person is talking plenty. From P conditional Q, the person says, therefore, P conditional, the very P conjunction Q. Then you make it well formed. And that is it. That's absorption. It can be very helpful. So make it your friend as well. All right. Now that we have revised our rules as best we can, it might look like, oh, doc, this one, people should go and do it on their own. It's not true. It's not everyone that even likes to see the symbols. So you have to make it accessible to them and to us all and give them reason to want to study the rules. People want to pass. They just need to be helped to know how to learn. And so don't let the rules scare you. This is the substance of deductive logic. Everything else we are doing, whether it is direct proof, indirect proof, predicate logic, what have you, is application of the rules. It's deduction. Free, taking it from something to something. You have to know them. If you don't know them, you can't be an expert in any of the proofs. It is just applying those rules. And so now that we have helped ourselves remember, we can use a few minutes left to mop up. Did you see conjunction somewhere on the line? Yes, I did. You will need that for indirect proof, where you have to sometimes intentionally go and pick one formula and join it with its negation to create a contradiction. It is an application of conjunction that helps you there. Then when you finish discharging with an indirect proof, what we did when we started, you have to now apply double negation to show that you should not have negated that conclusion to start with in the first place. So if you don't know double negation, is double negation a replacement rule or an inference rule? I want a curious answer.
A
Everyone.
A
replacement.
replacement.
Replacement rule. Very good. Do you know that if I don't want to say replacement rule, I can use another word? So you may go looking for replacement rule and you won't find it there. What can
Equivalent.
you
Equivalent.
equivalence rule? Well done. Oh, my people.
Equivalent.
I'm gonna one what you all get A, sir. You'll be happy,
Amen.
okay?
I receive it.
Amen. Then remember the disjunctive syllogism also, where you have two alternatives. As soon as you negate one of them, any one of them, you can conclude the other one, just as it was given. This is not the same as modus tollens, and so I know that you have taken note of that, and I'm happy we did this. Look at this is
Please, I
from.
have a question now.
Yes, I'll take your question now. Just whilst you're asking your question, everyone look on your screen. I projected something. I'll use the red pen to highlight it. Sir, please ask your question.
Yeah, Madam, please,
Everyone,
I
look
have
at
a
this.
little challenge with disjunctive syllogism. We know
Please
the
ask,
raw
what is the
one to.
challenge? Yes.
So, Madam, please, if you have not P disjunction Q, then
Yes.
the next premise you say that not Q. Can you conclude not
Yes.
P?
What do you think, say? The rule just says if you have two alternatives and you negate one of the alternatives, you can conclude the other one. You don't change the other one. You just conclude it
But
as it was given. So look on your
okay,
screen. You
but
said you have not P disjunction Q. Then you have
yes,
negated
please.
one of your alternatives, which is your Q. You have negated the Q. What can you now conclude? Say.
Please, is P sorry P not P disjunction Q, not Q.
Can you see my screen? I put it there. I get your point. If you have negated the Q, you want to know if I can
Yes,
conclude
please.
therefore not P.
Yes, please.
Yes, this is correct.
Okay.
Because what we negated was what the not Q. It wasn't a
Yes,
negation.
please.
Can you see that? Uh-huh.
Yes,
Now,
please.
if I have not P disjunction not Q, then in derivations, what we are doing in deductive logic, I must have not Q along one of the lines before I can conclude therefore what? Say. Therefore what?
Not P.
Not P.
Therefore not P. Please say, do you understand now?
No, Madam, please. That's the part I'm finding difficult.
No, relax. Do you understand this one? Don't lose track when I'm saying something. Don't think, oh, you got it. Oh. When I'm saying something else, I'm adding to what you thought you knew. This one, circled and numbered one. Do you understand that one?
Yes, Madam.
Oh, don't say yes if you don't understand it. Okay.
Madam,
If
please,
you don't
I get
understand,
it.
don't say yes. You get the one. But it is the example
Yes.
two that you have a problem with, isn't it? So let's do that again.
Yes, please.
Yes. Now you were given not P disjunction Q. Excuse me, not P disjunction, not Q. You want to negate one of the alternatives. You need a negation of any of the two alternatives. The alternatives are not P, the other one is not Q. So you want to negate one of them. If it is like not Q you want to negate, you have to find a negation of not Q. Then you can conclude the other one, which is not P. Finished.
Yeah, okay,
You
thank you,
see it?
though. Yes,
You are
please.
welcome. But perhaps you didn't have a negation of the not Q, then, but you rather had a negation of the P, the negation of the not P. That can still work. You can have a negation of the not P. Then it means you can conclude therefore what? Say. Oh, I hope it didn't go
Not
up.
Q. Not Q. Not
Very
Q.
good. Therefore not Q. And that is also correct. They are both disjunctive syllogism. This is it okay?
Yes, though. Thank you very much.
Very good. You are welcome. It's very helpful to someone. It will make your derivation process very easy. Now that we know a lot of these, you see that when you are asked to use direct proofs, everyone on your screen to show modus ponens or modus tollens or what have you, it is no longer a big deal. It's just more practice. So on our screen now, all this we've done in class, keep looking, please, my dear friends. We have P. This is an example. And this example uses only modus ponens and modus tollens. Oh, where is it? We have P, what we have been given. This is direct proof where you don't assume anything. You just go ahead and start preparing your meal from the resources given and produce the outcome wanted if you need to. No. So we are there. What were we given? We were given everyone. Oh, where is my thing? Hey dear, dig it out. My pen went off. It's on now. Everyone see. We have P, it's a premise. We have 2 is also a premise. So we have 3 premises and we are asked to prove. What is the conclusion we have been asked to prove? Everyone, please let me see if you are there.
R.
Well done.
R.
Very good. If it was indirect proof, what would we do from this? If it were indirect proof we're working with, what would we do? We negate the R and work with
Negating
what?
not R.
And work with not R. Everything. But here is direct proof, so we negate anything and assume anything. We just go straight to the point. And
Assume
so
not
there we
R.
go. Yes, please. So there we go. We are going to work now straightforward with our R, and that is what I said we go straight. We just go straight and work to arrive at the R that has been given there. And we do that by making sure that every line is clearly explained. We put a narration to the line, and the narration will always reference earlier lines. It won't reference itself because you are showing us how we got to that line. So it can be, I got to that line by passing through my line, Ankasa. It can't work that way, okay? So we have this, and this one is straightforward. It's in your workbook. I'm using your workbook now. So applied modus ponens on 1 and 2 give me Q then R. Then I'm applying modus ponens on 3 and 4. Please look. One of them, there was a correction that I think when I was going through it. So if I see it, I'll tell you. I think it might be here. 3 and 4 were here. 3 and 4. No, 3 and 4 is fine. It's modus ponens. Let's keep going. And that's all. We have proved R, which is what we are looking for. You don't discharge anything. You don't do any somersaulting. You are done. Okay? So we know direct proof. Everyone feel confident. You know direct proof. See that here, the next example, we didn't write a full premise. We just wrote P, representing premise. Okay? Then we apply the rules. The conclusion is what, everyone? Let's say it, go.
C.
Good. But you see that we are not assuming anything there. It's because we are still doing direct proof. Now that we have T,
Yes,
my
please.
friend, my dear friend who did the disjunctive syllogism with me, keep looking at. So here we are trying to prove T. So we do our skirmishes. We work out the rules against the given, trying to pull out what we are looking for. There is a T on line 3. So if I have to do anything, you see that I'll be looking at how to get rid of the antecedent, which is a negated disjunction. And one of the ways to do that is what you have been told in line 4. What is happening there? We, according to the one doing line 4, he or she says, I did modus tollens on 1 and 2. Is that correct? Yeah, I think so. Modus tollens says if I have P then Q and I negate my Q as it was given, I negate that, it will lead to a negation of the P. And that is what has happened there. That led me to line 4. Now I get line 5 from, says the paper, let's look at it, from 3 and 4, I get 5. Is that correct? Let's see. Modus ponens on 3 and 4. Yes, it's correct. Okay, so simplicity, a good revision of our direct proofs. I want to continue. So the same thing with disjunctive syllogism, very easy. We've done a lot of them. Then we worked out all these fine examples in class. Every example in the book for direct proof, we have done it. If we've gone to tutorial, we've done the rest. If you have questions, you have brought it, then we have trashed them out. You should be able to feel confident. Okay. There's a bit of HS and DS and MP in this one. Now, simplification and conjunction and whatnot. This one we did all in class. You can look at your notes, you will see. Then a bit of constructive dilemma, which I've helped you revise today for your confidence. You know, exportation. We've done a bit of absorption, and I think we are confidently building on. Now to indirect proof. These are all examples, plenty examples and work. The ones where we gave you the narration and asked you to fill in, instances where we gave only the premises and you were supposed to give us the narration. Others, we and so on and so forth. We twisted and turned to help you. Okay, we know double negation, we know De Morgan's theorems. These are all revisions. See how we are jumping now? We are done. Look at this. Very long proof where you use a bit of De Morgan and what have you. There's commutation, association. At this stage of your your deductive logic, you know how to apply from rules of replacement to inferences to what have you. You know them all already. Okay, it's just revision we are doing and a bit more of practice you need. Please keep looking. These are exercises asking you to use all the 19 valid argument forms from rules of inference to replacement to work on this. And you have done this already. Easy, right? If I say everybody do it, a large number of you can do what is on your screen. Okay. Now what? Now to indirect proof that we have already revised. Let's see. These ones we did in class. Check your notes. You see, we have done all. We have done all. Okay. Why am I telling you have done all? For your confidence. Okay. For your confidence. That's all. If you look at example 6, it's just so simple. If you want to make it complex, you will. If you want to make it simple, you can see. Look at it's BCD. And the conclusion you are looking for is also CDB. So there's some commutation and association. See that they are all conjunction to your left, and it's becoming conjunction to your right. This is not distribution. So there is a bit of commuting the positions and changing the bracket, which is association, and you will be done. Okay, you should see it. All right. All of those were direct proofs. Then now to the indirect, which we have already revised. We have helped ourselves with what to look out for when you are doing indirect proof. What we need to help ourselves remember, and then we go home, is what? The conditional proof, where you still have discharging because you do assumptions. What is the process for doing a conditional proof? Let's pick one and remember with that, and then we are done for the day. Anybody wants to help us remember the process? Nkrumah Felix, your hand is up. Is it to help us or you have a question? Jessica's hand is up to help us. I'll take your question shortly. Okay, don't forget it. Jessica, please help us remember how to do conditional proof. Very quickly, please. I have another engagement with my church folks that I can't even spare 5 minutes for. Why? So let's do this one. Yeah. If we have a conditional proof, what's the process?
You assume the antecedent.
I assume the antecedent. Sorry, because of your headpiece, I didn't hear you earlier. It's true. So a conditional proof works fine when you have a conclusion. Everyone keep watching my screen. You are being asked to prove a certain conclusion that oftentimes is itself what? A conditional. Okay, so look at example E. Let's take one that is very simple first. Look at E on your board, on your screen. You have been given C as your premise. Then you are being asked to prove, therefore, B, then C. What is the antecedent of this, your conclusion that you are to prove? Let's do it quickly, everyone. B, okay. So by conditional proof, very good. By conditional proof, you will have your line 1, which is a C. Then you start by saying 2. We have done it too. I'm just helping you remember. Okay. So you assume the B. Why? Because that is the antecedent of your conclusion. So assume that premise. And I tell you that assume, when you write the assume, because you are doing conditional proof, right? Assume CP for your own sake. Then you know what you are doing. Okay. Assume CP. Where is the thing there? Okay. Let's write it well. Very good. I think people have attended the tutorial. I'm told that you are not manga background. Hey, I said, I'm Martin. Someone has come. I'm here for tutorial. I say, hey, now you the tutorial. Is it every day that we do tutorial? It's good. Keep it up. Eh? So we are assuming the B only to work and prove what we are assuming B so that we can work to prove. Here we don't work to prove a contradiction. We are working to prove the consequent, the C. What logic is working for conditional proof? Modus ponens. If antecedent happens, then consequent must follow. So if you assume the antecedent B, you are working to prove the consequent C. As soon as you get the C, you can discharge from where you did the assumption to where you have proven the C. So what should I do for this one? If I have this and I'm trying to prove B conditional C, what do you think I can do? Hey, I don't have time. Work it. There's some addition that can work there. You can do some conjunction. You can do De Morgan. You can do material implication. Who wants to try? Hey, maybe there's a hand up. Very quickly. Felix, I'll take your question. Obin, do you want to try?
Okay.
Go ahead. Anybody wants to try? If you don't answer, I'll bring it in the IU. I'll bring it. Then that one you won't have a choice than to answer. Oh, my dear friends, please, I want to show you the nestling method before I go. So
Yeah,
nobody
dog, I
can
want
do
to
this
try.
one. Please try quickly. Yes. What do we do next? We have assumed our
So
antecedent, trying to prove the consequence. Yeah. What should we do
you
next?
see the third one, I'll use addition on so I'll do addition on C.
Addition on one. So it will become C or
Eh,
what?
sorry, one. Yes. So C disjunction D. Yes.
C disjunction B. Okay.
Yes,
That is
please.
add to
Then
one. You have done that. Then
yes,
four.
please. And then the fourth one, I will use material implication
On what?
on the three.
Material implication on three becomes
Even
not
even
Not
even before that, I
not
think I
C.
can do commutation on three.
conjunction.
Okay. So I should do commutation
Conditional
before.
B. Yes, please.
Okay. Then let's clean it. I'm sure that somebody is sitting there and say, hey, you ready? This is better. You are doing that, you know. That is so it's doable. Yes, it's doable. So I should do commutation on three. So that becomes B or C. Come
Yes.
on three. I've done that. Then five becomes what?
Then I'll use material implication
On what? Impl
on the four.
on four becomes not be
Not
conditional. Am I correct? Conditional C. I've done that. Everyone, remember we are trying to find C. Yeah, go ahead. What should I do next?
dog. I'll come back.
Hey. Go to tutorial. Which of my teeth? Say. The mother said, I'll come back. Hey, are you a it is possible? Oh, I love that one.
Disjunctive
People
was
are
one and
laughing. Don't worry, go and do that tutorial. Ajay. Don't worry. Okay, go to tutorial. When you go, hold the TA's next. Say, TA, my shit. We have done it in class, cry. Maybe you have forgotten. So go to tutorial and do it. The same thing. So, my dear friends, you are only working to prove the consequence, given that you have assumed the antecedent. As soon as you prove the C, you are done. Then you go and discharge from where you assumed to where you proved it. The same with example F. So look at F. Suppose you were asked to prove this. We are working with another pen now. Our time is up and I want to show you the nesting method. Okay, then we should be gone. Everyone watch this. If I have A then B then C, then I'm asked to and the second premise A then B, and I'm supposed to prove A then C. I can assume for line 3, I can assume what? Everyone, 1, 2, go. What should I assume by conditional proof?
You can assume the
Assume
antecedent.
A. Very good. And I write, no, we don't negate. My dear, that would have been indirect proof. Okay. When we are using indirect proof, that is where we negate something when we are assuming. Okay. For conditional proof, yes, for conditional proof, we make sure we have a conclusion that is a conditional, then we assume the antecedent to work to prove the consequent. That is what we learned. Okay. So we assume for conditional proof. Do you know that you could have been given a conclusion that is not originally a conditional, but it is in a form that can be changed into a conditional? Yeah. So suppose you are given not A disjunction C here. No problem. Let the not A disjunction C be here. But in your mind's eye, you know that not A disjunction C is the same as A conditional C by material implication. Okay. So you will change that in your mind. Leave what was given to you there, but change that in your mind by the equivalence of it, and then get the antecedent of that equivalence and work with it like this. When you finish everything and you discharge, then you come and write the original formula after your discharge and say, therefore, that one. Okay. So now let's do one and end with it. I want the one that is the nestling method one. Everyone now to our we're going to do that, but I want to see if I've covered everything in the
Dog.
workbook. Just a
Dog.
minute. Yes. We'll work on the
Please, I've been able,
whiteboard.
yeah, I've been able to get it.
Everybody will get it. We have even done it in class. I know. Look at this one. We've done it. If you remember, main campus people, we've done all this in class. I think later on it was Esther or someone that went to help someone. We finished this one on the screen. Okay, keep looking. So all these have been done. Your work is to help try, because whatever you will be asked to be from the workbook. If we ask you, Kofi, now where will it come from? Where should we ask you from? If we ask you Kofi and Adra, it's constructive dilemma and modus ponens and replacement rules. Yeah, and I will ask, what will we ask you? It's the same thing, just that we will ask you mixed up. So your ability to know it is what will help you know that this is what we've been doing all this while. That's all. Indirect proof, we've done it. I want to make sure I've covered everything. See this. Assume for something, show the contradiction, and show all this, and then you are done. Okay. I see that sometimes in your book you are told that it is from 9, from wherever we assumed, from 3 all the way to 9. So to avoid, if you include a 9 here, we will overlook it. I won't be too petty. But normally you are narrating what has happened before, which has resulted in what you have on that line. See that? That is the logic. Like, look at line 5. We are telling you what we have done to arrive at line 5. We say we distributed on 2. Look at line 6. We simplified on 5. Look at line 8. We conjoined 3 and 7, okay, to get to 8. So if we get to 9, we say from this all the way to 9. Maybe because we are showing that it's indirect proof. So either way, we will mark it. But let's go on. I want to end. Okay, everyone see. So that is it. These are all indirect proofs. A lot of examples there for you to work with. Here, you have been asked to prove the following are valid argument using both CP and IP. Keep looking, both of them, and other rules. So you can blend a bit of Ghana soup in the palm nut soup and it will become nkatikonto bear, that kind of thing. It's possible. Gobe plus beans, kumwachi, all put into one sauce. A bit of conditional proof. That's why when you are assuming, you would want to narrate which assumption you have used for your own reference where you are discharging, to show that I've done it from line 3 all the way to this line 9 that I'm on, and I used conditional proof to discharge this. And for the other one, I used indirect proof to do that, and so on and so forth. And that is it. The next one will be predicate. This is the nesting, nest. Akukobu nesting method. Keep watching. The nest of a bed. Okay. Yes, auntie. you do a sub within the sub. And I will use an example. Then after that, you see confidently, you will see that you are done with page 30. And you are going to start 31, which is predicate logic, after the break from Christmas. Okay. It's good for your mind. Now let's go and see the nesting method by way of one final example on conditional proof, and then we can go home. Okay. Where is it? And let's, yeah. So I want to, oh dear, forgot to press la first, and I've readmitted you and you were out. So let's stop sharing this one and share that. Back to my whiteboard. There we go. Please, you see my screen, right? We are out of here in 2 minutes after doing this and taking Felix's question. And we can do my check thing, and you can also go and cry or laugh. Some people are still crying. Someone told me that, dog, it's God that made you put the class online. Come here, I can't come. I said, my brother. You can't come, say. Share. You can't cry more than the bereaved do. Excuse me. So let's do the nesting method. Where is my thing? Everybody try it at home. I'm giving you the it is possible, people.
Madam, it is bad for. It is bad for.
Me don't disturb my body. My friend, my friend, he said he's a campaign manager. If you don't bring us, I confirm you see. All right.
Yeah, Ghana is Ghana.
But Ghana is a beautiful country, right? Ghana is a beautiful country. I love my nation.
Honorable bad for worry.
Hey, Lepamucho. What am I wishing? Okay, let's finish. Then you can tell you the lecture, they cried. Okay, now we have our screen. Let's finish. All right, so everyone, please, let's work on this. A conditional, open bracket, B conditional, C. That is premise 1. Okay, let's do 2 together. 2 will be B conditional, open bracket, C conditional, D. I'm sure those of you who are engaging tutorials would have seen that. That's also the second premise. Then I want you to prove, therefore, A conditional, open bracket, B conditional. I hope I can see this D. If you've done it, then it's good for you. If you haven't, let's do it together. Okay, those who haven't done it. So let me reduce this a bit. We are done, it's time, but let's get it rounded, then we can go. Watch. Now line 3, by conditional proof. What do we do at line 3? We assume what? Everyone, A. Okay. So assume for CP. If we have assumed this for CP, what are we going to work to prove? We're going to work to prove B conditional D, isn't it? Yeah. But I'm just showing you. So if you try to do that, you see that you will do a lot of somersaulting. It will take so long. So you can also, right after that, still assume, we did this in class, I just didn't show you how to discharge, and I want to show you that now. You can still assume the next line 4, and assume B. This B is this one, not some B up here. No, it's B still in the conclusion, because your conclusion's consequence is still a conditional, and so it has an antecedent B. Okay, so we are assuming that B is still an assumption of B for CP. But then it means when you are about to discharge, everyone watch. It means you will discharge the baby B, the baby antecedent, before you discharge the mother antecedent. That is what I want to show you. Okay. So now that we have done this second assumption, let's see whether our work will be easier. You see that our work will flow fast. Oh dear. Yes. You have to see they had this. So look at, with this, we can now go straight to 5. What can I arrive at? Very quickly. I can do C conditional D. Very good. You see it? I'll get C conditional D, and that is MP on which line and which line? 2 and 4. I hear only Esther's. Whose voice do I hear like that? It seems to be only
2 and 4.
2 and 4.
Okay.
Therefore, I want your response to this one.
2 and 4.
Madam Chairman of way, he cannot talk.
Let's finish. We'll tease him when we finish and take Felix's question. So now that we have C conditional D, we are looking for, everybody remember, because we did the second assumption of B, we are now working to prove what D. I hope people can see that. We only want to prove D. So from C conditional D, what can we do next? We have A and we have the other one at the top there. From 1 and 3, we can have B conditional C. Everyone can see that. How did we do it? MP on 1 and 3. Very good. Now we have B and C. So it means we can do, we learned something. Oh, please, look at, can you see? Look at this.
Yes.
I'm giving you a clue. So what can we conclude at that level? Everyone look at it and tell me.
Hypothetical
Hypothetical
syllogism.
Well done. HS on 5 and 6. Oh, let's finish. We'll tease him, don't worry. I'll be the lead teaser. But right now, then let's do the essentials. And see that we have just gotten B and D. But you see that we can't discharge yet. I hope everyone can see why. We assumed the B. So we have to now prove D. That's what we have to do. I was telling in class the last time. I wanted to take time to explain. Don't say that,
Correspondence
oh, but dog.
is
eh,
two
Thank you, my dear. Don't say that, dog. But originally, we were looking for B then D. That is not what we are looking for now. Because we have assumed the B also. So now we have to prove D, and that can easily be gotten, like your friend just said, by modus ponens 8 on.
and
The ladies, they do well in this course. MP on 4 and 7. Very good.
Adam,
4
all
and
be like
7.
the ladies are telling us.
Give us D. Okay. Now we have the D we are looking for. Remember, so let's do the discharging. Everyone watch. This is why I took a lot of time and put this last. Watch. We have arrived at the D, what we assumed B. Okay. So if I have B, this is how we discharge. We go to the B first. Why the B first? It's the baby one. And come and close it like this and say we have, that is what? We can now do 9. Very good. We can now do 9. And say 9 is B conditional. D. Very good. It is CP. Is CP from where to where? Everyone, from where? From
line 4 to 8.
Please, not on 3 yet. We are discharging the second assumption. Can you see that? 4 to 8. Mr. Wabin. If you stop here, we haven't finished the work. Okay, if we stop here, we are not done. We just discharge the first assumption. See, we have 2 assumptions. So we have to do the second one too. Okay, please, everyone, look at that. This is what I want you to remember. I've kept a lot of revision done, but we are not there. We do the second discharge. Please keep watching. And that one, we write.
Into brackets B conditional D.
We go to D now. Please watch number 10. Then here we go and state the whole conclusion, the whole thing. A conditional open bracket, B conditional D. And we tell everyone watching that this is no magic. We did conditional proof, that's CP, from where? From where we did the first assumption. From 3 all the way to 9. Do you see that we didn't say from 3 to 10? You see that we didn't say from 3 to 10? That wouldn't be correct.
Yeah.
You are narrating what preceded. So the one in the textbook, you can do a revision of that as well. And with this, you have done double discharge. This is what we are calling the nesting method. And you are nesting the eggs within. So there is something happening within the main discharge. That's all. Okay. Practice more tutorial. Felix, can I have your question now? Very quickly.
Still not
Okay. When using
Okay, I think I can end the recording and take Felix's question. The recording will share to the platform when I finish and I pull it out, okay? Go ahead, sir, with your question.
Okay. When using constructive diagonal, does